Please allow me to start by introducing my organization. The team working on mini-hydraulic energy includes Carmen Martinez, Teodoro Labrada, and myself, José Antonio Mancebo. We work at the Departments of Mechanical Engineering and Electrical Engineering at the Polytechnic University in Madrid. Our work attempts to contribute to the development of one of the most classic sources of energy, although one that still can be improved upon enormously, above all in developing countries such as those in Latin America and the Caribbean. In the local, regional context of these countries, we have observed that there are some important peculiarities in the sense that certain zones of the region have been able to benefit from such development. Peru is an example, with some previous support from the United Nations. Another very favorable factor is that the accessible water resources in the region are very important, especially with respect to the available flows and drops in level. However, the picture is not as rosy as it might seem, because the region is crisscrossed from north to south by the huge Andean Cordillera, which, apart from providing an abundance of water and the requisite drops in level, hinders communications tremendously, and infrastructure also remains scarce. This is especially the case of the large cordilleras of the Andes, the top of the jungle, and the jungle itself. The development of infrastructures is, or will be, also limited by environmental aspects, and this is therefore a third or fourth weakness that must be taken into account. With all this in mind, we have tried to gather the information designed for this module in several thematic blocks.
Teniendo en cuenta entonces los aspectos formulados anteriormente, hemos estructurado el material informativo diseñado para este módulo en varios bloques temáticos.
The first of these looks at the territory in general and, in particular, aims to gauge the available resources, which are essentially flows and drops in level. These are important aspects in the pre-design of any mini-hydro plant. So, once we have pinpointed our source of water, we then have to follow the path it takes so that we can install the civil engineering works that will bring the resource, the water, to our plant. Essentially, there are two types of plants, the type installed at the foot of a dam and those fed with a pipeline. Both are addressed in this material. We therefore provide some minimum indicators for the design of weirs or dams, inlet chambers and inlet towers. With all this, the water arrives at the turbine, which from the point of view of the hydraulics of the system is the main element. So, we shall be looking at the different types of turbine that can be used in these small hydro plants.
Y ahí nos detenemos bastante en la tipología de las turbinas aplicables.
Now, once we are familiar with the main types of turbine, those employing the principles of action and reaction, and we have been able to choose the type best suited to the particular case in hand, we see that the water follows its course out of the turbine and exits the suction tube in the direction of the discharge line. The water captured is therefore returned to the river and continues along its natural course. The energy produced is therefore completely renewable. The civil engineering works that must be built after the discharge conduit are also quite involved and form part of the overall design of the infrastructure of the plant. At a third stage, which also contains some very important elements. Once the hydraulic energy has been captured by the turbine, it must be passed through the electricity generator. And this involves a series of electromechanical devices that eventually transform our hydraulic energy into electrical energy and transports this to its destination for consumption. In the case of Latin American and Caribbean countries in which this type of technology can be installed, it will be necessary to look at isolated systems, and this in itself generates a vast number of management problems, because the excess, for example at night, is difficult to direct and transport if a pumping system is not available. Finally, in a fourth part, we shall explore two aspects that are of great importance in all projects of this kind. Here, I refer to viability. One constraint to viability is undoubtedly the economic one, and this cannot be avoided. If the project's economic viability offers a sufficiently high returns ratio, the project can be developed. If that ratio is too low, the project will be unviable. However, there is another aspect that will govern the environmental and even the ecological feasibility of the project. Let us recall that Latin American and Caribbean countries lie in a region that is susceptible to many different types of impact, and that the incidence of such impacts, especially drought and the construction of infrastructures, has been rising sharply in recent years, modeling and altering the territory to a considerable extent. Accordingly, our projects, our infrastructures, must respect the environment, and this requires a series of environmental studies to determine this aspect of viability. To finish, in the name of the Small Hydro Group, we hope that the module will be of benefit to you, and that it will in some way help to strengthen current technologies, all of them aimed at enabling universal access to energy.